Okay, hey folks. So I've been looking forward to this one for a long time, and I'm glad you're with us. We were having a discussion a little bit about climate jargon a little while back, and Rob Levin, one of our board members, mentioned that he spends his days as an editor and publisher wrestling with historians, economists, epidemiologists, and professors about clear language. And so, as Rob said, quote, I browbeat them occasionally, dropping in a short definition of a word. So that gave me an idea because Rob's kind of proud of his browbeating proficiency, I mean, ability. And so we have several professors in our membership, and I've got a couple of them here with us tonight. So since you can't talk sustainability without talking a little trash, the great browbeating was born. And with Theodosia Wade and Melissa Hayes, other fellow board members eager to take on this challenge, let's get ready to rumble. So in this corner, hailing from North Carolina by way of newspaper assignments in Colorado, Arizona, Rhode Island, and the Atlanta Journal-Constitution, and as a freelance publisher, our resident editor extraordinaire, Rob Levin. And in this corner, brought to us by Oxford College of Emory University, two of the best scientific minds of our organization.
Oh, yes.
We have Professor Emeritus of Pedagogy. And speaking of terminology, I'll ask you someday what the heck that means. In biology, Theodosia Wade, and our current Assistant Professor of Environmental Sciences, Dr. Melissa Hayes. So with that, I'm going to go over to the sideline and enjoy this event and turn it over to Rob. Thank you.
Good evening. It's been a long time since I've been able to browbeat professors because I spent the 9 best years of my life in the 8th grade being browbeaten. So it's time for payback. So Melissa, let's start with you. So
okay, bring it on. I'm ready.
We were going to talk about weather versus climate. So help me out. So let's take New England. Some people say the weather in New England can change by the hour. But by and large, it's hot in the summer, it's cold in the winter. And yet people talk about how they love that type of climate. So I'm confused. The difference between weather and climate, what would that be?
Easiest way to think about it is climate is what you expect, weather is what you get. So we can think about weather. If you look out your window at any one moment, what is it doing outside? What's the temperature? What kind of, is it raining? Is it snowing? Is it hailing? What's the wind doing? When you look at your window, what it's actually doing at any moment is going to be your weather. Now, if you start monitoring the weather for long periods of time, you start noticing some patterns, right? It's hot in the summer, it's cold in winter. And so if you get enough data, usually it's about maybe 30 years or more, you can start seeing these trends and start getting some expectations. And that's what your climate is. Your climate is an easy way to think about it. It's kind of long-term weather patterns. And this is really important because you start thinking about it. You've got, someone living in the Southeast saying, oh man, this is a colder than normal year. I don't know what everyone's talking about with the climate's changing. You can't say anything about climate from a single year's worth of weather. You got to think about what that weather is doing over long periods of time to get a sense of what climate's doing. And just because the climate in your area is changing differently than climates in other places, it doesn't mean that the whole global climate isn't changing. So it's thinking about short-term versus long-term, what you expect to happen versus what actually is happening, weather versus climate.
Okay, I give you an A.
Yes.
That's one for our team.
One for our team. No questions, no pushback. I didn't use any words that were too jargony.
Nope, they were all 3 syllables or less. That's good.
Winning, I love it.
Okay, so Theodosia, there are probably no 2 phrases more charged with emotion than climate change and global warming. So is one man-made and the other not? Help us out. Why do people get these confused, or are they the same?
Yeah, it's interesting to see over a period of time since the 80s, 70s and 80s and 90s, and how we've use those terms. I think it started mostly with global warming as the term that people used a lot. It kind of got a political charge to it. And so I think people tried to avoid using it at that point. They more recently talk about climate change, and some of it goes back to what Melissa was saying. So when you think about global warming, that's kind of only one aspect of climate change. So you've got sea level rise, you've got melting glaciers, you've got wild weather patterns. You have a lot of other components to climate change than just global warming. And so that's one of the reasons, sort of a shift in the way we use that term. We see the term climate change much more often now. And then the other part is what Melissa said. Sometimes somebody will say, oh, this isn't global warming. This year's much colder than last winter, or something like that. The polar vortex has shifted, and it's brought a lot of cold air down into the south. And so people will say, it's just, it must be a joke because it's colder this year than it was last year. And again, it's where you are in the world. It's now versus last year. But when you look at the overall trends, we do see global warming occurring, and then lots of other climate things going on with that, along with that. And so climate change is really what people use now more often.
Okay, what do you prefer, climate change?
I use climate change, and part of that is, I think about internationally. So we've just gotten out of the UN climate conference, and we talk about a lot of climate change, climate conferences, things. I just think it's a much broader, more accurate term for what we see going on with the climate at this point.
Okay.
Another fun term that kind of goes with that as well, I've heard people use, is climate weirding. The climate's just getting weirder, and it's more unpredictable, and things are just getting weird. You're getting snow earlier or later, or in places you don't expect, and it's not just change, it's just getting weird.
Yeah, I've heard that too. Climate weirding. Yeah.
So Melissa, you're a scientist, and I can barely spell the word chemistry. So my head begins to spin when I try to decipher the difference between carbon and CO2. Do either of these have anything to do with greenhouse gases, and how important is carbon to life on Earth?
Yeah, so this is a hard one for me to think about, because both of my graduate degrees are in biogeochemistry. So I can really get into this jargon, super fun, and make it super fancy, but obviously that's not helpful, and it'll just give you fodder to attack me with. So I'm going to try to break it down a little bit. Carbon is just an element. It is a naturally occurring element. You think about the periodic table of elements, maybe from when you were in school. Carbon is an element that's on there. It is in a lot of different compounds, but it's really connected to biology. You may have heard that, we are carbon-based life forms. And when we're looking for life in other parts of the universe, we're looking for carbon-based life forms. That just means the stuff that we're made of. A lot of important biological things, sugars, proteins, DNA, tissue, all contains a lot of carbon. We find carbon in non-biological things as well, in different rocks and minerals. So if you have a diamond ring, that's just a whole bunch of carbon atoms stuck together in one way. And if you stick those carbon atoms together in a different way, you get graphite, which is what we have in our pencils. And that's really soft and breaks easily. So carbon's everywhere. It's in biology. It's naturally occurring. We've got carbon everywhere. When we think about carbon, it's part of also some compounds that you mentioned, thinking about carbon dioxide. So if we have one carbon molecule stuck together with two oxygen molecules, we get carbon dioxide, or CO2. And this is just one of many different kinds of greenhouse gases. So I'm going to step back and talk about greenhouse gases, and then we'll come back to carbon dioxide. Greenhouse gases are just certain gases that occur in our atmosphere that trap heat. There's all kinds of cool chemical processes and bonds and things we don't have to worry about. But the basic point is these compounds, these gases trap heat, and sunlight can pass through them. But when the heat is trying to escape, the compounds hold on to them. Now, greenhouse gases has now got this term like they're bad. We don't want them. We want to get rid of all greenhouse gases on our planet, and that's a really bad idea. We need some greenhouse gases because it keeps our planet warm so that all the living things don't freeze to death. So we need some greenhouse gases. The problem is that we have too many greenhouse gases right now. Long before humans were on our planet, we had greenhouse gases. So there are some natural sources of greenhouse gases. Volcanic eruptions are a really good example. They put out things like water vapor, CO2, things like that. But now that we've got humans, the largest source of greenhouse gases is coming from human activity. And the compound that's most often produced by humans is the carbon dioxide, or a CO2. So that's why we hear about CO2 the most often, because it's the stuff that humans are making the most of. So we need, some of it is naturally occurring, but so much of it we have now is, we just have way too much of it because we are now producing it instead of just the planet producing it. There are other greenhouse gases that are actually worse than carbon dioxide because they trap more heat. So something like methane, that's another one that we hear often as well. And so oftentimes people will talk about CO2 equivalents or equivalent. And so what they're trying to do is this CO2 equivalent is a measure used to compare the ability of different compounds to trap heat. So if someone says, hey, the warming potential of methane is 25, right? It has a CO2 equivalent of 25. What that means is for every unit of methane, so let's say if you've got 1 ton of methane, that is going to warm the atmosphere the same as 25 tons of CO2. Because they're trying to make some level or some measurement that you can compare all these different greenhouse gases relative to the one that's most common, that people are most familiar with, which is the CO2.
Okay, so methane, an example, cattle, is that methane?
Yeah, so thinking about cow flatulence is producing methane. Some, burning of some natural gas contains some methane as well.
Landfill gas.
Yep, landfill gas. As you put all your garbage in a landfill, you have microbes and bacteria that are in that landfill munching on it. And as a byproduct, they give off methane as a gas. And so there's less of it in the atmosphere, but it traps more heat. So it causes more warming.
Okay.
So it's about 25 times stronger of a greenhouse gas than carbon dioxide.
Okay. So Theodosia, we're going to talk about carbon neutral or neutrality. Okay.
Yeah. So
I'm going to read you. This is my meeting. I'm going to read you a definition of carbon neutrality.
Okay.
I need you to give me a better definition.
Okay.
Carbon neutrality is achieved when anthropogenic CO2 emissions are balanced globally by anthropogenic carbon dioxide removals over a specified period. Wow. Try telling that to someone at a Christmas party.
Oh, I love that word, anthropogenic. And they talk about this as being sometimes the Anthropocene. There's an organization called the Anthropocene Alliance that I work with at times. So that term is just being thrown all over the place right now. And again, it means human impact. So you're talking about carbon dioxide that, like Melissa said, is not just the natural part of the carbon cycle, but is the human addition of additional carbon dioxide.
So give me a simpler definition of carbon neutral.
Carbon neutral is really what you're thinking about. You talk about net zero a lot of times in that as well, or climate neutral. You hear a lot of those. And I would like to add that the UN climate change has just come out with their major goal is to reach net zero of greenhouse gas emissions by 2050. And then with having benchmarks along the way. So they're also using that net zero or carbon neutral term. And it's they use a lot of those terms sort of interchangeably. But really what you're looking at is the balance between the amount of greenhouse gases that are being produced. Those we call sometimes a carbon source. So they are being put into the atmosphere from different sources. And then we think about that in terms of balancing with the amount that's being removed from the atmosphere. So you can see that the goal is to get to zero. If we could have the amount that's going in balanced off by the amount that's coming out, then we would reach this net zero or carbon neutral or climate neutral part that we would, goal that we would like to reach. The other term that is thrown around a lot is drawdown.
Yeah, now that's something that sounds like a gunfight at the OK Corral.
It does. That's I hadn't thought about that before, but that's true. So Sustainable Newton is partnering with Drawdown Georgia, and Drawdown Georgia gets its name from obviously drawdown. And that's really the point at which the greenhouse gases are going up in terms of being emitted into the atmosphere. And drawdown is the point at which they start reducing. So the graph would reach a peak and then start tapering off. And that would be really, that decline is where you're talking about the drawdown. And that's, that's really the goal for a lot of our climate talks right now are how do we get to net zero? It's kind of like we used to say, how do you reduce your carbon footprint? You're trying to lower your carbon footprint by doing things like purchasing offsets. So if I have to travel to New York City to see somebody and I have to go by airplane and my carbon footprint for that event is really high, I can purchase offsets through different companies, and they actually invest in places that we call carbon sinks. So a carbon sink is an area that absorbs carbon dioxide, so like a forest. So we talk a lot about forest reforestation, planting trees in areas where forests were, or enhancing forests, growing the forest, because we're trying to, again, trees are so good at taking carbon dioxide out of the atmosphere. And they do that through the process of photosynthesis, that they're making their own food. And in the process, they're taking carbon dioxide out of the atmosphere to do that. And so they become a great carbon sink. The oceans are great carbon sinks. The phytoplankton there is carrying out photosynthesis. And again, that's using carbon dioxide out of the atmosphere. A lot of that carbon gets tied up into sediment. So when an organism is a shelled organism, so when you see all those shells on the beach, those are calcium carbonate shells. And that's another way of tying up carbon. And so those carbon sinks are really important when we think about the opposite, and that is the carbon sources, our burning of fossil fuels, burning trash in your backyard. I mean, burning, you've made your leaf pile, and instead of putting it somewhere and letting it decompose over time, you want to get rid of those sticks and leaves really quickly. So you burn them and you put a lot of carbon dioxide immediately into the atmosphere. So we have sources and then we have sinks. And all of that, does that help? Do I get an A+ for that? Or do you think I need a little more explanation?
See me after class.
Okay. Gotcha.
So Melissa, on 1.5 degrees Celsius,
Yep.
it just seems to be a phrase that's out there without a lot of context to it. It doesn't, to me, it just doesn't seem like a big number. What is so important about this number, and why can't they define it better than just saying 1.5 degrees Celsius, like it's shop talk among people who don't want the outsiders to know what they're talking about? And how does this apply to the phrase tipping point other than a book I read?
Yes. So when everyone talks about 1.5 degrees, this is this idea that scientists have used all these really fancy computer modeling, and they have determined that we want to try to keep the global average temperature at having only increased 1.5 degrees since pre-industrial times. Pre-industrial can be like this huge range. So most scientists use around 1850 to 1900. So right around the turn of the century. What was the temperature then? And we want to try to keep our temperature now to not get any warmer than 1.5 degrees from that initial time. Now, there was some debate about maybe we want to keep it at 2 degrees, but the models have gotten more accurate, and we really are sitting at this 1.5 degrees boundary of we don't want to get any warmer than 1.5 degrees from where it was at the turn of the century. The reason this is because this is the idea that if it gets much warmer than 1.5 degrees Celsius from pre-industrial times, there is all kinds of pretty serious climate change impacts that are going on. So if we can keep the temperature less than that, we are being protected from the most serious climate change impacts. Currently, we're at about 1 degree warmer than pre-industrial times. And so we are only about 0.5 degree away from, some people call it a tipping point. This idea that once you've reached a certain point, things start to get really bad.
Really
so
fast.
We want to,
They get bad really fast.
They get really bad really fast. So if we can keep our temperature from getting above 1.5 degrees from what the temperature was in pre-industrial times, we can be protected from kind of the worst things out there. If it starts to get warmer than that, we start to see all kinds of things happening. Way worse heat waves, worse droughts, worse flooding, more sea level rise. We could expose millions and millions of more people in coastal areas to having problems. The rate of extinction almost doubles if we go to just 2 degrees above pre-industrial times versus 1.5 degree. The range for which mosquitoes can live and carry nasty diseases like malaria spreads. Food crops suffer, so we start to have massive food shortages. There's all these things that are happening now, but they all get really, really, really bad if it gets warmer than 1.5 degrees Celsius from that pre-industrial time. It's hard to think about. You're like 1 degree, 1.5 degree, like you said, in New England, it can change, 30 degrees in a single day. So why is this 1.5 degrees? You want to think about that. This is a global average temperature. So it's not any one place. It's not thinking about weather of what it is this day versus this day. It's thinking about if we take an average temperature of our globe, how do we, that's that kind of temperature. If you think about like a biological system, you think about yourself, how much worse do you feel when your body increases by 2 or 3 degrees Fahrenheit?
So
right?
That's an interesting point, because I read a story about heat stroke.
Yeah.
What happens to your body during heat stroke, and it's almost irreversible.
Yeah.
And your organs start shutting down one by one.
Mm-hmm.
So are you saying this tipping point is the Earth having a heat stroke? Is that
kind of, but it's not that once this happens, you can't do anything about it. It's once it happens, it gets a lot harder to deal with the problems. the problems get a lot worse, and it's a lot harder, and it's going to take more time to recover from that. So, and that's really important to remember, because people are like, well, well, once we 1.5 degrees, if they have in their mind, well, we can't do anything about it, then people stop trying to make changes. So it's never so far gone that we can't do anything about it, but it's going to take longer to solve the problem. It's going to take more money, more resources. It's just a lot harder to deal with if we let it get so bad, if we let it get more than that 1.5 degrees Celsius above pre-industrial times.
Okay. So Theodosia, fossil fuels, I think most people kind of understand what fossil fuels are. The substance were made long ago, and dead bodies and dead plants and dead whatever. I get confused with clean energy. So can you tell me the difference between clean energy, green energy, and renewable energy?
Yeah, so those are all terms that we throw around a lot. We talk about fossil fuels also as being non-renewable. So sometimes you talk about renewables and non-renewables. Non-renewable because of what you just said. It takes millions and millions of years to produce those, coal and gas and oil and methane. A lot of that takes many, many years to make. And so it's really not renewable in our lifetime. It takes so long to do. So they can sort of run out, if you will. And they talk about, when will we run out of these stores of fossil fuels in the ground? A lot of people would say, leave it in the ground. There's a big movement to say, leave it in the ground because it's causing so much trouble for us when we extract it and then we burn it, and we cause a lot more carbon in our atmosphere and get to the 1.5 degree change that we're talking about, that Melissa just talked about. So that's the fuels that we would like to get away from. The ones we want to move toward, we talk about them as clean because we think of them as not producing the emissions, not adding all that carbon to the atmosphere like burning fossil fuels do. So for example, the solar panels on my house are creating electricity without burning coal. And that's a good thing because coal, adds a lot of carbon to the atmosphere. We talk about it being renewable because really, you can talk about the sun as being perpetual. It's a perpetual resource. It's not running out anytime soon. Wind energy is another renewable. It's clean because of its emissions being very reduced, and it's renewable because it's constantly being renewed within our lifetime. So we talk about a lot of things like tidal power now, even through the waves and wave action. Geothermal is big. Melissa, I know, has been to Iceland, and that's, one of the countries that we think about as being just geothermal energy everywhere there. But energy efficiency is also sometimes talked about when you talk about green energy, because anything you can do to make something a little more energy efficient means it uses less energy. So for example, if you switch all your household light bulbs from incandescent to LEDs, then you get the amount of energy that each one of those bulbs uses is much less, and your electric bill goes down because you can actually see those savings and see the fact that those save a lot of energy. Energy Star appliances, a lot of these kinds of things we can actually switch over and use real easily. So those terms are thrown around a lot. But again, if we can make the switch, a lot of times we talked about switching from coal, for example, in our electricity over to say solar or wind, and the intermediate was going to get us from the coal to the new clean renewables was going to be natural gas or methane. And that natural gas is also a fossil fuel. So, we've gotten kind of stuck. A lot of our power plants are natural gas power plants now, which is better than coal, but we'd still like to move away from fossil fuels and towards greener energy sources.
And I'll add a quick thing to that. You can't put the word clean in front of a fossil fuel and really change its impact, right? There's a big marketing lobbying push for clean coal. And that somehow is better than regular coal. And it's what we call greenwashing, making something sound sustainable, and it has no green connected to it whatsoever. So clean coal doesn't exist. Just because you call it clean, it doesn't make the process clean.
So a moment ago, you mentioned carbon footprint. But we talk about wind energy and solar energy. Doesn't it take a pretty big footprint to make wind turbine blades and solar panels and batteries for electric vehicles? Aren't those huge carbon footprints?
Yeah, now we are going to have some in those, the minerals that they have to, the lithium batteries, the things that they have to extract to be able to make those batteries do have some impact on us, clearly. But I'm thinking about, we talked about electric vehicles, and the big question for people is, oh, hey, you're driving an electric vehicle. That's great. But when you plug it in at night and your power is coming from coal, all you're doing is switching those emissions from the tailpipe of your car to the smokestack of that power plant. So, you do have to think about some of the trade-offs and some of the things that it's not always an easy calculation to figure out your carbon footprint and to figure out the footprint of all kinds of energy. I do think one of the things that's been really cool about our renewables, particularly wind and solar in the United States, is that it's a big market. It's a great opportunity for new jobs and training for people going into those fields. And it's been a real has had a real economically positive impact because of that kind of thing. But, again, you do have some things you've got to think about when you're producing solar panels. What are the materials that go into that? When you're, producing wind turbine, how are you making the steel that makes those blades? There are all kinds of, you've got to do sort of that, Melissa, help me out. What is it called? Something chain. Follow
like the life cycle chain, or the
yeah,
energy?
it's more like the life cycle chain. That's not the term I'm thinking about, but it's the whole idea of from beginning to end with any technology or with any product. You can think about what the impact is all along the way.
Mm-hmm. I mean, and the thing is, you're always going to have to put energy in to get energy out, right? You're going to have to spend energy to build any of these things. And the idea is not to come up with an energy source that doesn't have any impact, right? That's not viable, but it's a significantly lower impact than our fossil fuels. And Maurice has chimed in with value chain for thinking about all those different steps.
Mm-hmm.
Yeah.
Okay. All right. So, Melissa, while you have the stage, I want to talk to you about two things. One is climate adaptation.
Mm-hmm.
And then I want to ask you about climate mitigation.
Okay.
So to me, the adaptation just sounds defeatist. It's like you're saying, get over it, deal with it. This is what you got. You're going to have to learn to live with it. Is that what it means?
Pretty much, yeah. So
thanks.
It's finding ways to live with it. So if you picture you got a boat and it's got a leak and you're starting to take on water and you're sinking. Climate adaptations would be equivalent to trying to scoop out the water from your sinking boat. A climate mitigation would be, let's seal that leak so we stop taking on more water. So if a climate adaptation would be, you say, okay, these are the changes that are coming. These are the negative impacts. Let's take some action to try to reduce the damage that they're going to cause. But it's all on the backside, right? It is all focused on dealing with the effects of the problem as opposed to actually solving the root of the problem. And that's where climate mitigation comes in. This is, you are trying to address the root cause of the climate change. You are trying to actually reduce the emissions, you're trying to increase storage, you were trying to do something to stop the climate from changing, as opposed to just the climate is changing, how do we live with it?
So this to me seems like mitigation is like almost an environmental cousin to drawdown, net zero, carbon neutral.
Yeah, mitigation is just all the different steps that we can take to actually stop and hopefully reverse the changes to our climate. So building renewable energies, making our appliances more energy efficient, increasing the size of our forests so we're pulling down more carbon dioxide, right? Anything that we can do that reduces our emission and increases our capture or storage of carbon dioxide falls under the category of mitigation. With adaptation, you may say, okay, well, we know it's going to get hotter, it's going to get drier, so we're going to have more wildfires. Let's prepare for a longer, more intense wildfire season. We know that sea level is going to rise as a result of climate change. Let's build bigger seawalls to protect our communities. But we're not actually trying to stop the sea level from rising. So you kind of have two different perspectives. Now, personally, I think at our current situation, we've got to do both. Right? We've got to prepare for the changes that are already happening and the changes that are coming and that we can't stop, because you have this time lag between when you emit greenhouse gases and when they're actually having an impact. So if we were to stop producing all greenhouse gases right now, today, no more greenhouse gases were being produced, the amount of CO2 in the atmosphere would still increase for a period of time.
Wow.
So you have this, there's changes that are taking place that are coming and that are here. And so we have to have adaptations, but we want to think about how do we stop it from keep getting worse and have these mitigations that we're doing alongside with the adaptations. Just doing the adaptations, not enough to actually make a difference and save people's lives.
I think about too, Melissa, when we are talking about the UN talks, the climate talks, I mean, they always talk about mitigation. What are the solutions? What are the mitigation strategies that your country will use to draw down to get to net zero?
Yes.
And then they also always talk about, adaptation. Every nation, every community is impacted by climate change in some way. So I'm in Charleston, and I love your example about the seawall, because we have the battery wall here on the downtown area, and there's a big plan right now to extend that and to make it higher. And again, that's not doing anything to help with sea level rise. It's just trying to manage sea level rise and to prevent sea level rise from taking more lives, from destroying businesses, destroying homes, and that sort of thing. So yeah, I think that's, that they certainly talk about that globally, both of those as part of the way you address climate change.
Okay. So while you have the mic, Theodosia, so carbon sequestration.
Yeah.
Which I see is the long-term removal or capture of carbon dioxide. Why can't they just call it catching carbon? Why use 5 syllables when 2 will do?
That's I don't know, but yeah, carbon sequestration, carbon capture and sequestration. We talk about carbon sinks and carbon sources also along in those same vein. And you're thinking about how all that kind of works together, the whole carbon cycle of how that works. And again, there are natural carbon sinks which do sequester carbon. So they are part of that carbon sequestration. So like forests, like Melissa said, adding more trees, planting trees is a big one tree planted. I have a friend who usually gives me a little gift at once a year around Christmas time, and it's in my honor to one tree planted. And it's this national sort of movement to plant trees. If you're trying to buy a carbon offset for a trip, like we mentioned earlier, you can invest in a tree planting. So those are great ways to capture carbon and to sequester it, to hold it, and not allow it to be in the atmosphere where it can cause global warming and climate change. So again, forests, oceans, soils, a lot of soils. There are techniques for farming now that we have that help sequester carbon in the soil. So you're not doing a lot of tilling and turning over soils, but you're letting a lot of it kind of lay fallow, and you're allowing those soils to hold the carbon dioxide there. There are also artificial techniques. So I liked it when Melissa talked about clean coal. One of the things they talk about with clean coal is this, well, with coal, we can actually capture the carbon dioxide now, and we can pump it underground into these deposits in the aquifers, and we can get it under the ocean. We can deposit it under the ocean. And so they're really experimenting with a lot of these techniques. I think part of the problem is this technology is so new. We don't know how long that carbon dioxide is going to stay underground in these deposits. Is it going to bubble up, sooner rather than later and still be a problem? That gets to be a problem. So it's kind of hard to tell.
I'll add one thing.
Yeah.
With all these great technologies, these are really important, because if we think about how much CO2 is in the atmosphere, we aren't ever going to be able to decrease the amount of CO2 in the atmosphere by just decreasing emissions. So we kind of have to have this 1-2 punch of, we need to decrease emissions, but we have to increase how we are actually sucking carbon dioxide out of the atmosphere. And all this idea of sequestration are ways to do that second part of sucking that carbon out of the atmosphere. And we need both of these strategies to actually have climate mitigation, to use the fancy terminology.
The other thing I thought was so interesting, we talk a lot about the way we grow our food, and moving to a plant-based diet also helps with carbon emissions, because our livestock, and Melissa mentioned flatulence, which you always think about, but also belching. So burping. Cattle have that 4 system. They have 4 different stomachs. They chew their cud, it goes down to one stomach, it gets worked on, then it comes back up, and they chew it again, and they swallow it again. It goes back down through that system. And there's a lot of bacteria in there working on that grassy material and creating a lot of methane. So cattle in particular, but I was reading the other day where they've done a little bit of work looking at seaweed. So they don't have to give the cattle total seaweed to eat, but it's like a seaweed supplement, a 10% or 1%, I've forgotten the percentage of their feed. If they add seaweed to it, it reduces the methane that they produce by like 70 to 80%. So we're always finding new ways, new technologies that will help with a lot of this, all these greenhouse gases that we're trying to reduce to get us to that 1.5 degree.
Melissa, you have anything you want to add before we conclude this session?
No, I think Theodosia covered things quite well, and she did a good job explaining those fancy terms. And
so I get an A?
I think so. But I guess the question,
I am roundly educated and defeated at the same time in this session. So I thank you both for your time, and everybody, we hope you have a good night. Maurice, you're out there somewhere? Maurice is going to bed.
Yeah,
he's just sequestering carbon.
Here.
Right.
Yes.
Sequestered yes. Maurice.
Oh, I don't know if laughs count as the same as belches and other things, but that was wonderful. Thank y'all so much. I think you all get an A.
Excellent.
Yes, I think so. And hopefully our viewers out there will think the same thing. And I would say to people watching this, if you're still watching this, that, if there are other terms that we didn't cover or things that we could go a little deeper in, we would love to do that.
Yeah.
there's so much in the news these days, from Glasgow, from Washington, from so many places about climate actions that we're taking, and understanding what, why, and how much is real important. So thank you guys for engaging like this, and hopefully we can do more of this. It's been a lot of fun. So.
Would love it. We'll take you on anytime, Rob.
Okay, I'm ready.
All right, so you folks out there watching, give us your questions for the rematch, and we'll see you soon. Thanks.
All right. Yes.
Thank you. Bye-bye, everybody.
Bye.
Bye. Bye.